Mic check 1, 2. Mic check 1, 2. Mic check 1, 2. Mic check 1, 2. Hello, Rancheroos. It is time for the RanchCast. Haven't seen you all in a couple of weeks. Been on the road a little bit, but really happy to see you all today. So, I'm going to jump right in. First, we'll talk about things that are going on in the community. You can see me live at a couple different places and jumping right into here. All right. So, if you'd like to join the conversation today, as always, go to slack.rancher.io. Put in your email address. You can join us in the Rancher Slack workspace and then come join us in the RanchCast channel. So if you're in the RanchCast channel, come say hi, ask questions, make fun of what I'm wearing, all the above. So would love to see you out there today. I keep an eye on that over to my left while we're going, and there's a little bit of a delay. It's anywhere between 8 and 15 seconds. So you make fun of me, I'll see it 15 seconds later, and then I'll start laughing about it. So today, live events happening. We're going quick today, about 45 minutes because today there is a Rancher Online meetup. So the Rancher Online meetup is just like a normal meetup that you would go to, except you don't get charged to sign up like Meetup will do to us now, and there's no pizza. So, but there'll be a hands-on with Rancher 2.3 at the Enterprise Cluster Command Center. They'll actually be talking about the Windows feature that we're talking about automating today. So a little bit backwards. So I'll go about 45 minutes to an hour, and then you all can jump right into that if you want to sign up. Rancher.com/online meetups. It helps when I transition over to my screen. So rancher.com/online meetups to talk about that today. As I mentioned before, slack.rancher.io. Put in your email address and then come join us in the channel. It's called The RanchCast. Again, ask questions, make fun of my outfit, whatever you'd like today. In addition, you'll have some opportunities to see me live. I will be speaking at Tech Bash coming up in November. This is at the Kalahari Resort and Conference Center in the Poconos. This is like their third or fourth year now. I've been there every year but one. This is so really happy to represent Rancher there. Give some talk on Kubernetes, talk DevOps, things of that nature. I think I'm doing two talks, one on Kubernetes in Azure AKS, and one on breaking the monolith, which is near and dear to my heart because I built lots of monoliths back in the day. In addition, Philly.net Code Camp is coming up this week. Now, they are .NET really in name only these days. They cover the gauntlet. They've been around forever. I've been speaking there now for close to a decade. But I'll be doing a full day on Friday. I think that class is already full on zero to Kubernetes. Do go check that out. But I'll be doing a talk on Kubernetes on Saturday, as well as a talk on becoming a confident meetup organizer in like 8 easy years. So I'll be doing those two talks on Saturday, as well as juggling kids and all the other stuff that I love to do. Again, the Rancher Online meetup right after this today. If you're in the, let's see, Portland, Phoenix, or Minneapolis areas, we are doing the Lighthouse Roadshow. So this is a full day, half day of discussion about business-oriented things and strategy-oriented things, and a half day of focused technology stack in the enterprise. Our partners there will be AWS, GitLab, Aqua, and Portworx. We are also doing these in Europe. So if you're listening from Europe, lighthouseroadshow.com, /North/America. And we're doing a bunch of these with Microsoft Azure, GitHub, and Aqua. So do check that out if you're in either of those areas. As always, past episodes of the RanchCast are available at youtube.com/theranchcast. We are live now from YouTube as well. We can skip my Google Calendar for the day. So let's talk Terraform and Rancher. So Rancher 2.3 launched this week. Part of Rancher 2.3 is the ability to do Windows nodes with Windows Server containers. So if you want to get a copy of the latest Rancher, you can go out to github.com/rancher/releases and actually take a look at the copy there. Oh, look at that, 2.3.1, coming out soon. So the other thing, so everything that you're looking at today, I've already written code for. So I've pre-baked it because it takes about 20 minutes to start up. It needs to be a little more efficient. But if you'd like to see that, it's github.com/me, Jason Van Brackle/Cattle Drive. So Cattle Drive is a community reference architecture we're all working on together. I did all the work for today inside the Cattle Drive repo. I've separated things into separate Terraform modules. We're going to focus on a couple of them today. but the platform that I have up and running right now was created that way. And let me, so first and foremost, I'm gonna make sure I have my link and password. So I already spun that up. I'm gonna do it off screen because I will be showing off a password. Terraform output. It helps when I'm in the right directory. So I'm going to my directory with this code and running a Terraform output. So that I can get my links and my password. So I already have this up and running today. This was built entirely via automation. So the automation that is here in the cattle drive Terraform module is what was used to build this. Now you will need your own TFR file with any Let's Encrypt information that you want. This is a full Let's Encrypt cert. I actually took advantage of Azure's ability to create DNS entries on public IPs to make this happen quickly. And I think that's the default for this. So first and foremost, you're going to need the Azure CLI. This will depend on your setup. Windows, Linux. I'm on an Ubuntu Linux machine here, but go ahead and install the Azure CLI. You're also going to want Terraform. So it's at terraform.io. I'll open that up as well. I'll make sure all these links are in the comments as well. So you want Terraform as well. You can install it via Snap, or you can download it as well. It works in Windows. It works in Linux. Actually, some of this stuff is actually more helpful from Windows machines because we're dealing with Windows servers and having to RDP in and finding software to RDP for other operating systems is fine, but the support can be touchy sometimes. So let's talk about automating all of these things. So I'm going to bring open my code window, bring it over, and actually make it larger so y'all can see it. Now, this has changed quite a bit from our previous versions of this application. Everything is driven here in the main module. It uses the Azure RM Terraform Provider, and this is why you need the Azure CLI. It used to be I was spinning up Azure Service Principals and then using the Service Principals to log in. And I was having issues with that and decided, you know what, I will adopt that later down the line. I got to do some information. I got to do some study on Azure RBAC and how to go about like fine-grained Azure RBAC control. Now there is a Service Principal module in here. It does work. I haven't been able to apply it to a Kubernetes cluster to configure the Cloud Control Manager yet. So first things first, let's talk about some of the substrate. You're going to need an Azure resource group. This just being a geographic region where things live and they all live together within the network, and the subnets will actually create two subnets here, one for Rancher and one for the Kubernetes cluster managed by Rancher. We see that here in these modules. And it's a fairly simple module. Every Terraform module, for those unfamiliar, generally has a main, a variables, and output. So variables are the things that are either coming in through the command line or through module call. The output are things that are coming out of the module, so you can call them in either other modules or out to the command line. And then main is the main driver. So this one's really simple. It's just creating the resource group and then spitting out the resource group for using later in other modules. So going down through main now. We need a bunch of nodes. Now, I like putting things in local variables. This is just a local Terraform variable. Now, these are all Linux machines. I just used, I think, Ubuntu 1604 LTS right there in the SKU. So I added my admin username, a key path for SSH credentials. I do all my logins to SSH. We're not doing bash nodes today. It's a pretty simple example. I'm going to use D2S v3s because they're plenty fast, premium storage, and I'm going to then use Ubuntu 1604. And make sure I'm using Docker version 1809. Now, this works with any version of Docker supported by the Rancher Terms of Service. If you're interested in the Rancher Terms of Service, again, I'll put it in the links. But you go to rancher.com, all the way down to the bottom. I think there's terms of service here. At least there used to be. There it is, terms of service. So it actually has our support matrix for those of you who are not just open source Apache users, but those of you who are customers. They are served by these SLAs. But the nice thing about this page is it also has our support matrix for versions of Rancher or version of Rancher OS. What other things that we support as far as Linux distributions and versions of Docker. So always good for reference there. Again, I will put that in the comments below. So next up, thank you, screen. And this thing is, as always, is a work in progress. Back up to main. Okay, we have our nodes. So we create our Rancher networks. We had a network for Rancher and a network for the managed cluster. So these two resource groups are actually geographically separate. One I have in East US, one I have in East US 2. I believe I put the Rancher in East US 2, and I put the Kate's cluster in East US. But again, these are just using the network module here, and the network module is just creating subnets. So I'm creating a subnet for my virtual network, or so I'm creating my virtual network and my subnet for my network as well, and then spitting out. I'm not even spitting out anything there. I just, I just need a network to work from. Next, I have my different node types. So my etcd nodes, my control plane nodes, and my worker nodes. I'm passing in my resource group how many nodes I want, which I have set in my variables. My default is 1. So if you pull this up, you don't need to set all these variables. I have a lot of defaults in there that are completely sane. Where my subnet is, and then a starting index and then that node definition we looked at. The starting index is something for Azure. So if we go into our node module, and our node module is slightly more complicated. And let's just make this smaller so we have more screen real estate to look at. You know what? I'm just going to turn that off completely. So every node will have a public IP. It'll have a NIC, which will be attached to the public IP, and then a private IP. Now, I'm managing all of my IPs statically. I'm doing that because of the way the Terraform Azure Resource Managed Provider works. So if I create them dynamically, it will mean that I don't have my IP address until that is attached to the VM, and it doesn't really happen until the end of the Terraform run. So in my earlier Terraform modules, if you look at the ones out in github.com/JasonVanBrackle/Terraform modules, you'll actually see me use the output in my Bootstrap script. So this is using a combination of Terraform and Bash. I actually create an RKE YAML file with the output from Terraform, because at that point, I know here that I'll actually have my IP addresses. So I wanted to get around that, manage the whole network myself. That way I had control over not just my IP addresses, but I had them immediately and could keep everything into one Terraform module. This is also where this starting index comes in. So because I'm making multiple sets of nodes, I need to know what my starting index is, and then I have this +4. Azure reserves the first couple of IP addresses in the subnet for its own purposes. I found that out because I just Terraform spitting errors at me. I spent a lot of hours putting this together and tripped over a lot of things that were either Azure provider related or Terraform related or order of operations related. It was a lot of fun. And then everything in here is Terraform 12 syntax. So if you're using 11, it's not going to work. I use the 12 syntax because there's some nice things with 12 syntax. So create a virtual machine. These are all pretty standard things in a virtual machine. Attach it to a network, to a NIC, to a resource group. The OS profile. So you can see here, I wanted Docker set up via Cloud Init. So Docker is not set up on this node intentionally. So I have this Cloud Init template. You have the ability to fill in the blank template with an object with each item that's being filled in. So my Docker version, my admin username, and of course my additional command, which in this case is, this is different node template. Yeah, so the template with my additional commands actually I use it to join Rancher on my other ones. That might be a bug. I'm going to check that out later. I don't think it's a bug, but it might be a bug. We can see here the Cloud Init template. It's going to call an additional command. The default for that additional command, if I don't send one in, is just a sleep command. Otherwise, oh no, that's not a bug. That's a replace, so it's flexible. This uses the install Docker GitHub repo to install the Docker version that I say, and then add the admin user into the Docker group. So that's all the Cloud Init is doing. Now that Cloud Init takes 2 to 3 minutes to run based on the node and things like that. So I've got actually a timer in the node that pauses it. I could make that a little more, a little more interesting by like SSHing in and putting something in there that I know when the process is done. I haven't done that yet, just didn't have the time. But we can see here, the custom data is where our Cloud Init file goes for Linux machines. Cloud Init is not covered for Windows machines, so we solve that a different way. And then we have our key path set up for our SSH keys. And then we have our wait for Cloud Init. So I've wait 3 minutes, sleep for 180 seconds, wait for Cloud Init to run, and then go about our day. And then I have some output variables that will be used further down as far as the public IPs, the private IPs, and the nodes themselves. So I use this later on down in the Terraform module as well. So etcd control plane worker for Rancher, and then I put a front-end load balancer. This is an Azure front-end load balancer, so it's a layer 4 load balancer. But the nice thing is if you give it a domain name label, you can get a fully qualified domain name that Let's Encrypt can talk to create Let's Encrypt proper cert chain, which makes life a lot easier. Now, I have some Cloudflare stuff in here as well. If you're a Cloudflare customer, you could use the Cloudflare template instead. I have that commented out of this specific one, but we'll actually go through and create the Cloudflare zones for you using the 2.0 version of Cloudflare Provider. Some of my earlier Cloudflare stuff in that other repo uses the 1.6 version. The 2.0 version is very recent, and I actually had to do some modifications to this code for the 2.0.1 to work properly. So back to our main module. Actually, I should be checking for questions. I usually check for questions every once in a while. Nothing yet. So front-end load balancer. So now, at that point, we have our Rancher cluster up and running. Let's see, where's my install? Rancher cluster, that has to happen after the install. No, that's fine. Yeah, part of the additional commands that run in the node command. Let's see, post, where is that? Network. This is why we have Control F, because I just don't remember what it is off the top of my head. Yeah. So I use a null resource quite a bit for anything that I have to send out to a shell, because I want as much of this in the Terraform as I can, so I'm not like bashing here and terraforming there and bashing again and terraforming again. So everything is encapsulated into this Terraform. So if you need to run a shell script from within, from the Terraform, you can use the null resource. And you can see here, once the front-end load balancer is done, once the front-end load balancer is done, we go about and initialize. We initialize Helm on the Kubernetes cluster. We install Cert Manager as well, all per the documentation. And then we install Rancher. So the install, for anybody who's been through our docs, this should look really familiar. Install Cert Manager looks a lot like installing Cert Manager. Installing Rancher with I use the Let's Encrypt one, which is so I'm basically adding latest stable and alpha into my Helm repos. And if you want to use 2.3, 2.3 is not in the stable repo yet. It's in the latest repo. So you want to grab Rancher latest, grab 2.3.0. Now I'm using Let's Encrypt. If you want to use self-sign, there's a script for that as well. So you have to include a Let's Encrypt email in your variables file and a Let's Encrypt environment. And then I use the host name. That host name is the one coming from Azure. In this case, if you use Cloudflare, send the Cloudflare one in. Just make sure that your NS lookup, that you can resolve that new name as soon as it's created or as soon as it's available in Cloudflare. You might need a sleep in there or something like that. So again, for those of you just joining us, I see a few people have joined us. If you want the code for this, it's in Jason Van Breckel / Cattle Drive. Now, there is a blog post with a something very similar to what I'm doing now coming out this week. I'll make sure to link to that in the comments as well, and that'll be on the Rancher blog. I'll probably mirror it to my personal blog later, just for posterity's sake, in case Rancher decides to do other things. But I'll make sure that link, at least the Rancher link, is there. So instead of doing bash scripting to stand up my my Rancher cluster, I'm using the RKE Terraform Provider. Now, this is an open source provider, so it's not in the the proper like Terraform providers list. If I go to docs providers, it doesn't exist here. It is actually an open source provider. You have to install it separately. There is a file for that. So I have this. Where is this? Set up RKE Terraform Provider. So I put a version in, it goes and downloads the release from the GitHub repo and actually installs it, at least in Linux, to the Terraform dplugins file for your user. So you'll have access then to that Terraform plugin, and then we're using that to create RKE. So if I go into, where is this? Back to my main. Before my install Rancher, that is here. So the front-end load balancer gets created, and then the RKE cluster gets created. So it depends on those other modules running to have all the nodes ready. That's why I have this depends on. And then this uses Terraform's dynamic syntax. So you could basically say, give it a group of things to spin through, and for each of them, create content. So I'm actually using the RKE cluster provider or the RKE cluster resource to define this Terraform cluster. Now, behind the scenes, this will actually create the RKE config file and run RKE up. But it's really cool to have it all in Terraform. So this is a really useful open source project that is not a Rancher project, that is just a Rancher fan. So if you want to get that, I'll make sure the comments are in there for the Terraform provider. But if you've looked at the RKE YAML format, the examples in here look a lot like our RKE YAML format, just in Terraform format. Once that's done, though, we're going to grab this local file so we have access to the kube cluster. So it's not just sitting there on the RKE file that we have to pull off via SSH. So RKE cluster gets created with our different node types. Now, installing, doing the tiller setup for Helm, I do that right in the RKE add-ons. You could do that similar to our documentation with kubectl commands. It's up to you. I want to experiment with the add-on section here for this provider because I had not used it yet, and it worked like a charm. So then I have this local file, and it grabs that kube config. We're going to use that over and over again, both for the Rancher install and for initializing Helm and setting up cert managers. If you can go into each one of these shell files, you have initializing Helm. Again, this should look familiar if you've read the Rancher documentation. The only thing we're adding is that we're also making sure we're specifying our kube config from the one that was generated by the RKE provider. The cert manager setup as well, which is just right to 091. If you have to do an upgrade from anything earlier than 091, go watch Adrian Gowen's video. So Adrian, one of the members of our team, who is, I believe, in product marketing. I don't know what his actual thing is that he does. He's awesome. So if you go to Adrian, was it Goins.tv, I think was the actual right one. It goes right to his YouTube channel, and he did a great thing in his YouTube channel around, Let's Encrypt shutting you down. Because anybody who's using earlier versions of Let's Encrypt has now gotten messages from Let's Encrypt saying, hey, this is going away. You need to upgrade to 9.1. So he went through the process, a very painful process of upgrading, just based on documentation issues and just some idiosyncrasies of the upgrade process. It's not a simple process, so go check that out. Thank you, Adrian. Seriously. Nothing new on Slack while I'm talking. So installing Cert Manager and then installing Rancher. Again, this is just consistent with our documentation with some fill in the blanks for the way Terraform works. And again, you can grab this code. It's right on github.com/jasonvanbrackle/cattle-drive. And again, we do some waiting for the ingress for Rancher to spin up, a little bit of time there, 30 seconds, just make sure everything's working before we start trying to talk to it. So now we've gone through all the Terraform stuff and all the non-Rancher stuff. So now we're going to talk about the Terraform provider for Rancher 2. And we're going to show two things in this today. One is bootstrapping Rancher, and two is setting up a Kubernetes cluster with Windows. So bootstrapping. I created a Rancher bootstrap module, if you want, and it is the bootstrap provider. So the provider works two ways. It works in an admin way that allows you to do things to the Rancher cluster, but it's also a bootstrap provider, and that bootstrap provider allows you to bootstrap up the Rancher server. So it's just like doing a Rancher HA install or a Rancher single node install, and then when you log in, where it asks you for your admin password and for your server URL, that's what this module is for. So this Rancher bootstrap module is for specifically that. The documentation on that is actually really good. The team who puts that together did a great job. Great. If you go to the Rancher provider, and there's an example here for using the bootstrap, and I followed this documentation to create this code. So let's look through it. So in Terraform, you can alias providers. So we're going to alias one as bootstrap. It needs the Rancher URL. Again, that's the URL that I passed in. We taught bootstrap, and I actually don't need it to be insecure because I've got a full-blown cert chain via Let's Encrypt, but if you're using self-signed search, you want this insecure to be true. Now, the resource, we actually use the bootstrap resource with the bootstrap provider, and we give it an admin password. So this is where we actually set our admin password. Now, I have all the passwords of this are randomly generated, which is, so you could, there's some things about this that are not production ready, like how I handle passwords. I don't have a key value store that's secure, things of that nature. But this does randomly generate passwords, which of course Terraform spits out the randomly generated string to the console. So if you're going to save the logs, you also have to redact the logs. So, second provider. Again, with the Rancher 2 provider, I alias this one admin, and this is where I'm actually logging in. So the really cool thing is the Bootstrap provider will provide you with an admin token for doing admin level things. So I don't have to log in and create my admin token. I get one from the Bootstrap provider that I can use down the line. So I give it my URL, I give my admin token again, insecure true. If you're using self-signed certs, you're going to want that. And then I'm just setting my server URL. So I'm using the Rancher setting resource, and I'm just setting the server URL setting, and setting the value to my URL. That would be the equivalent of me just going into here, going into Rancher for the first time, and when I log in for the first time, remember it asked me for my admin password and my server URL. So everything you're looking at on this was created by this Terraform module. I did very little post except for something I was blogging about. That blog will come out for later. So and that's it. Just about everything else you can do in Rancher can be done through the Terraform provider as far as setting up state. So setting up search, setting up clusters, setting up projects and namespaces, that can all be done from within this provider. So if you have you have the ability now with Terraform to set up a known good over and over and over again. We're automating all the things because we want to really master that first way of DevOps. That idea that we have full control of our workflows, not just from a software development standpoint, from an infrastructure standpoint, being able to spit up from zero. This is also big for things like disaster recovery and business continuity, things of that nature. Any questions out from the Slack? Nope, nothing out there. Just some people hanging out. So we now have Rancher set up in this Terraform and bootstrapped as far as where we are here. Going back to our main module, the cluster module. So we're now going to create a cluster. And I can see here, I create the definition of the cluster before I even create the nodes. Now I'm going to change it up so I create the nodes and then the cluster later, just from a speed standpoint, because this thing's taking like 30 minutes to run right now, and I want it down to like, I don't know, 15, 10. I want it to be at the speed of Azure. So as fast as Azure can create things, I want to be able to create things as well. So cluster name again, APIs. Let's go look at the cluster module. So it takes in some variables in cluster, API tokens, resource group, and these are the Azure related things at the bottom. And then main. Again, we're using the Rancher 2 provider. We need the URL. I'm taking the admin token that was created by the Bootstrap and reusing it. And then I'm just creating a custom cluster. So this would be the equivalent of me going into the UI, hitting custom, and then setting some options. Now, this Windows preferred cluster item that shows up on your Windows cluster. So if I go back into Rancher for a second, let's actually just create a definition. I'm going to do a cluster custom Windows test. And we're just going to go in, hit flannel, enable Windows support, VXLAN. So this is very similar to the definition that I created in Terraform. And then I'll have my Windows node. So thing one about the Terraform provider, you won't get this screen. So if I go back and I edit the existing cluster that I have created, I'm just going to hit done here. If I go and edit this one that I already created, I don't have any Windows options. I don't even see them. And I think that's because I can't set, if I go to this other one here and I edit the cluster and I edit this YAML, I have down at the bottom here, where is it? There's like a prefer Windows setting that I saw on here. I don't see it now. Nope, I have one Windows. Yep. Highlight all. Let's go to the next one. Did I miss it somewhere? Windows, 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 Windows. No. I thought I remember seeing a prefer Windows in here. Maybe I'm wrong. I saw that in one of my tests, and I thought that was maybe the reason why I didn't see this when I went into the cluster. I'll put in a GitHub issue for that, so that when you go into these ones that are Terraform created, you still get all your UI goodies, but the idea being that we have that, we have the whole UI available. We just don't in this one. So back to my global and back to my Terraform. Now, there's a couple things you have to set for Flannel to work with Windows. So the backend port, the backend type, and the VNI. So I said, basically what I did was I created one by hand. I looked at the RKE file, created one by hand that was not Windows, looked at the RKE file, and just kind of did a diff to figure out what was different. So these don't get created automatically for you, so you have to go and create them. Now, I've commented out the cloud provider stuff. I'm having an issue with my service principals working properly. It was causing the installation of this to fail. I'll look into it. It'll probably be fixed by next week. I just haven't done it yet. But that's it. This is a custom RKE cluster that is just ready for nodes to join. That now we come to some fun. So nodes joining. Back to main. We create our nodes. Now you'll notice here, I now have this command to execute. So this is part of our essentially cloud init file. We're adding a cloud init file. We're adding the Linux node command. So, and then the role of that Linux node command. So what I'm doing is I'm basically taking from the provider. If you go to the cluster, I'm grabbing a specific, here, I'm going to grab this, I'm going to search that so I can find that node command. Nope, is it not node command? Node, let's find command. Oh, where is it? Cluster auth. No, I'm in the right one. I'm in cluster. Oh, it's part of the RKE config. If I go into the RKE config, yes, that's not helpful. Terraform documentation. I'm missing this somewhere. Where am I missing this? Oh, I'm looking at data. I need the actual resource. That's what I'm looking at wrong. Cluster. And then now I should have a node command. So part of the spec for the Rancher 2 provider is a cluster, also has an RKE config. The RKE config has a cluster registration token, and the cluster registration token has a node command and a Windows node command. That is the equivalent of going into your Rancher cluster and grabbing this command down here. So if I grab Windows, I get this command. If I grab Linux, I grab this command. Now, getting Terraform to grok this is not fun. I simplified this greatly. I took PowerShell out of the equation. I'm just doing the Docker run with the appropriate things, and I'll show you how I did that because I spent hours kind of debugging that. So let's look at the node command, and we'll look at the Windows node commands. With the Linux one, and let's grab into this node command. Back up into our node module, main. So the template file, the cloud init in our additional command. So basically I'm running a replace on this. I'm basically saying, grab that command and put some arguments on it. Now the default is a sleep command. So the sleep command completely ignores these extra arguments. But that command executes the Linux node command I put in the public IP address and the internal address for the private IP. That way, Terraform knows which is which, RKE knows which is which, and Rancher knows which is which, so that we have proper routing in the cluster, so everything internal to the cluster routes internal to the cluster. So that when we go back and put network security groups, that being Azure firewalls, everything just works. And that's it. So the Docker command's the easy one. The next one is the Windows commands. Going back to our main, we have the Windows node creation, and then joining the Rancher module. So there's two reasons for this. One is there's no SSH on the Windows server by default. Two, trying to set up WinRM in a secure manner is not fun. I also didn't have time to do it. And three, there is a custom script extension that allows you to use the VM agent to execute custom scripts post-provision. So that's what we use. We actually use the post-provision command. So if we go to the Windows node module, we go to main, this will look a lot like one for the Linux nodes. The only difference is I'm sitting in Windows node. So talk about the Windows node I used. I'm using the Microsoft Windows Server publisher, the Windows Server SKU, and I'm using Data Center 1903 with containers. That means Docker is already installed and enabled. It's kind of a shortcut. It's really nice. You're going to want 1809 or later. Windows operating system or Windows containers are connected to the operating system they're generated with. So an 1809 container will run at 1809 or in a Hyper-V isolated 1903. A 1903 container can only run in 1903. It will run in the preview 1909 with the Hyper-V isolation. So keep that in mind because Kubernetes doesn't currently support Hyper-V isolation. So the Windows servers you create have to have the version of containers you want to run. And that's actually, go read your Kubernetes documentation, the intro to Windows. I'll put this in the links. Intro to Windows container, Windows support in Kubernetes. You see, I read it a lot. There's lots and lots and lots and lots and lots of caveats to running Windows servers in Kubernetes versus their Linux counterparts. The way the networking layers work, the way some of the storage works, a lot of other things. So go check that out. The SIG Windows team did a tremendous job working with SIG docs to make sure this was well documented. So data center core. So we create the node, and then we join the node using a custom script extension. And there's another gotcha here I'll let you know about. So I don't think there's anything here I have to comment on. We've already talked about VMs working, image reference. Yeah, there's nothing special about this node creation, only that there's no cloud init file. So here I use the join rancher module. The join rancher module is using an Azure custom script extension. So if I go to my join rancher module and I go to main, you can see here I do a bunch of replacing. So I take that Windows node command with that PowerShell in there and I remove the PowerShell. I remove that whole IEX stuff. And I make sure that I add the worker call in, and I pipe the command that I create into PowerShell. So it kind of inverts the call that we give, but makes it Terraform compatible. So I played with that quite a bit to make that work, and that works awesome. I'm actually probably going to put a pull request into actually the Rancher code base or the Terraform code base, the Rancher, whichever one uses that to change up that call, because this call is simpler. And plus, IEX is kind of a no-no. We don't use IEX in the PowerShell world. I'm a PowerShell guy, so because it's an evoke expression. It's like an eval in JavaScript. So we join Rancher, and you can see here I'm using a Microsoft Compute custom script extension, and all I'm doing is calling, again, that Docker command that we've created, and also giving it the internal address and the public address as well, so the Windows node can spin up. So this all takes about 30 minutes for it to spin up. So that's something for you to know. It takes a while. And even once the cluster is created, it takes a while for the nodes to join, and then it takes a little bit longer for the Windows node to get its feet together. So I did a lot of like logging into the Windows server, making sure it wasn't stuck. Logging into the Linux nodes, making sure they weren't stuck, and they don't get stuck. It just takes a little while. So patience is key. So once you have that up, you're here with a full-blown hybrid model Windows. There's a few things we have to worry about when it comes to Kubernetes and Windows alongside Linux. Because most of your Helm charts, most of your YAML examples, they don't take into account multiple OS because it's always just been Linux. So we have to worry about targeting. We have to worry about targeting the proper nodes. The first thing I do, and I'm going to actually add this into the Rancher join scripts, I taint the Windows node. So for those unfamiliar, Kubernetes has a concept of taints and tolerances. And it quite literally means, hey, don't schedule here, don't execute here. It's really common. The standard practice is to automatically taint a no schedule on your control plane and a no execute on your etcd, so that your workloads don't end up here in anywhere in your control plane or in your Kubernetes brain. That way, you're not eating Kubernetes with your workloads. So I also add a Windows only no schedule taint to the Windows node. That means everything I schedule that's a normal like Linux thing won't end up here. And you can do this either from the UI or the API or from kubectl. If you want to do it from the UI, hit edit, go down to taints, and I just add it Windows only equals true, and give it a no schedule. So that was thing one I did after provisioning. Next up, I schedule something. So let's actually schedule. I've got something I'm working on for bringing ancient applications into Kubernetes. I've got this chat app that I've been playing around with from the four guys with Walla. Another blog post is coming out soon. I'll make sure that gets in the comments as well. Before I do that, any questions? No questions from Twitch or from Slack. So let's go ahead and actually create something. So we're going to go to cluster. Go into hybrid, go into default. I've already got two of them running because I did this last night for my blog post, but let's just do a third. Let's do a deploy. So I'm going to grab my chat application or human software. That's my repo. /chat latest. And then we'll just call this chat 3. It'll be a deployment in the default namespace. I'm going to give it a node port. Now this thing listens on 80 because it's just a web app. Public and port name. That's right. Chat 3 port. Publish it on 80. We'll let it assign a node port for us. And then node scheduling. I want this on Windows OS. So the other thing I forgot to mention here, let's just duplicate that really fast. If you go out here, go out to your nodes, your node labels, and this is a Kubernetes thing. This isn't a Rancher thing. If I edit my nodes and look at my labels, we have a kubernetes.io/OS label for Windows. If you go look at your Linux nodes, they say Linux. So we're going to take advantage of that. So for our targeting. Now there is I can't add a taint from or a tolerance for my taint from here. That is something that is coming down the road as well. But that because you need that really for this type of thing. So I'm going to add a rule for kubernetes.io/OS equals Windows. So it ends up there. I'm going to launch that. And it will fail. It will fail because I don't have the tolerance. It would tell me that I have a node that's tainted that I don't have a tolerance for. So I'm going to actually grab the YAML from here because these were actually just created using YAML. I'm going to grab that tolerance as well. To the toleration. Let's see, spec containers. Where's my tolerations? Right here. So grab my Windows toleration, and I'm going to just do the same thing here. I'm going to go back into my deployment. I'm going to edit the YAML. Like I said, I know there's a GitHub issue out on this, and this is containers. Containers goes down to here before DNS policy, and we put our toleration right here, and then we will save that, and just like that, we are now scheduling. Now, the scheduling will take a while the first time because the base Windows Server container with some stuff in it is like 5 gigs. Now, I've run this a bunch of times, so this is sped up because that's already in the local repo of that specific node. And if we go right into here and we hit the endpoint, we have our ancient ASP Classic app ready to go. So I've got a discussion around getting actual applications running from things like ASP Classic and older that will be coming out soon. So we're just at 12:45. So again, if you want to check out the code that I used to spin this up today, it's all available. GitHub.com/me/cattle drive. It's the exact code that we use today to spin this up. Like I said, it'll take about a half an hour to run, give or take, depending on your machine, depending on how Azure's behaving, and everything is in here. If you have any questions, you can find me out on Twitter, twitter.com/JasonVanBrackle. Also, if you're one of our Slack users, go into the Slack channel. I'm at JVV. That's Julia Victor Bravo, and that's because there were a lot of Jason Van Brackles born between 1979 and 1983. So if you have any questions, let me know. Now that we're about 15 minutes away from the Rancher Online Meetups, if you want to see more about this Windows feature, more about the Istio feature, and the new things that came with Rancher 2.3, you could sign up right now, rancher.com/online meetups, and go ahead and sign up for today's online meeting on Rancher 2.3 with the Enterprise Cluster Command Center. With that, thank you all for a wonderful time. Thanks for being here with me. I'm going to do a bonus RanchCast sometime tomorrow. We're going to talk about this the classic ASP app scenario. I'll have that up on our Slack and on Twitter later today. I'm going to do one tomorrow. I don't know the time yet. I just got to see where it fits in my calendar. So bonus RanchCast tomorrow if you're listening on moving an ASP Classic app into Kubernetes. Again, there's a blog post coming out with all this stuff as well. I'll have all the links in the comments on the YouTube video. I'll make sure that gets blasted out to Slack today and to Twitter. And thank you all for watching. I will see you next time.